Hello everyone, welcome to solve this math Olympiad geometry challenge. And here we have a nice right triangle in which the length of its one side is m square and other two sides is m cubed and m to the power of 4. So here we solve this problem for the values of m. So here first you see that this is a right triangle, and we know that in right triangle the side opposite to the right angle is called the hypotenuse, or in other words the longest side is called the hypotenuse, and the side which join these two angles is known as its base, and this side is called the perpendicular of this right triangle. And we also know one thing about the right triangle is that the Pythagoras theorem is also hold in these types of triangle. So the Pythagoras theorem is stated as hypotenuse square equals to base square plus perpendicular square. So this is called the Pythagoras theorem. So now we have hypotenuse is m to the power of 4, perpendicular is m cubed, and our base is m squared. So now we substitute these three values in this nice Pythagoras formula. So this implies that we have our hypotenuse is m to the power of 4. So we substitute it here. It will becomes m to the power of 4 and its whole square equals to our base is m square. So it will becomes m square and its whole square plus perpendicular is m cubed and its whole square. So this is the our three values of the given right triangle. So now we again simplify these three values, and this equation implies that we have m to the power of 4 and its whole square. So these two exponents are multiplied by each other and we get m to the power of 8 equals to m to the power of 4 plus m to the power of 6. So now here we move these two values in the left hand side, and this will becomes in the form of m to the power of 8 minus m to the power of 4 minus m to the power of 6, and this whole equation equals to 0. So here you see that we have m to the power of 4 be the common term on these three terms, so that we will take common m to the power of 4, and the remaining terms are m to the power of 4 minus 1 minus m squared, and this whole equation equals to 0. So now we convert this equation in two cases. So our first case is we write m to the power of 4 equals to 0, and the second case is we write m to the power of 4 minus 1 minus m square equals to 0. So in the next step you will see here we have m to the power of 4. When we take a fourth root on both of the sides, then you get here the value of m equals to 0. So now first we discuss this value of m, and now if we take square on m, then you get here m squared equals to 0. So if m squared equals to 0, it means that this side length of this triangle becomes 0. So if this side triangle is 0, it means that it is not possible, because the length of any side of triangle is non-zero, so it cannot be a 0. So if it is equals to 0, then it means that this case is not possible and we rejected this case. So here we just proceed this case only, and in this case we need to find the values of m. So now we rearrange the terms and we rewrite this equation as m to the power of 4 minus m squared minus 1 equals to 0. And here we rewrite this equation as we write m to the power of 4 as m squared and its whole squared minus m squared minus 1 equals to 0. So now you see here this equation will becomes quadratic in m squared variable. So now here we use, or we first convert this equation in standard quadratic form, so that we will take here y equals to m square. So when we substitute this m square equals to y in this equation, so this equation will be written as y square minus y minus 1 equals to 0. So this will becomes quadratic in standard form. So that here we use the quadratic formula, and in order to use the quadratic formula we need to take the coefficients of this equation, and the coefficients are a equals to 1, b equals to minus 1, and c equals to minus 1. So now our quadratic formula will be written as y equals to minus b plus minus square root of b square minus 4 times of AC divided by 2 times of A. And now we put the values of A, B and C in this quadratic formula. So now we move towards to put the values of A, B, C here, and we get, you see here we have the value of B is minus 1. So when we substitute it here, it will becomes minus times of minus 1 plus minus square root of b square. So b is minus 1 square minus 4 times of a is 1, and c is minus 1 and its whole square root divided by 2 times of a, and our a is 1. And now in the next step we need a little bit simplifications here. So we make simplifications here, and you see that we have minus times of minus becomes plus 1 plus minus square root of minus 1 square is plus 1, and this minus times of minus plus, and 4 times of 1 is 4 divided by 2. So here you get the value is 1 plus minus square root of 5 divided by 2. So now we convert this equation into cases. So now first we write the positive value. So the positive value is 1 plus square root 5 divided by 2, and now we put the negative value, and our negative value is 1 minus square root of 5 divided by 2. So here we back substitute the value of y, and in the start of the problem we take here our y equals to m square. So this implies that m squared equals to 1 plus square root of 5 divided by 2, and similarly in this case we have m squared equals to 1 minus square root of 5 divided by 2. So now first we discuss this case, and in this case you see here this value is less than 0. So if this value less than 0, it means that our m square is less than 0, and when our m square is less than 0, it means that this side is negative. But we know that m square be the side length of the given right triangle, so it cannot be possible, and triangle has a negative length, so we rejected this case and we have only this case. So in this case we take the square root on both of the sides and we choose the positive value. So we get here m equals to square root of 1 plus square root of 5 divided by 2. So here when we simplify this equation, this term, so we approximately get the value of m is 1.272. So this is the our final answer of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.